Welcome to today's video, where we will discuss a common problem that can arise when working with PyTorch code. The problem at hand involves attempting to backwards through the same graph multiple times and encountering errors related to accessing saved tensors after they have been freed. This issue can be quite frustrating, but fear not, as we will delve into the solution in detail. In the solution provided, it was highlighted that one of the root causes of the problem is the creation of multiple leaf nodes, specifically with a variable ref_image being defined with requires_grad equals true. This results in a computation graph being formed, but reused every iteration, leading to multiple backward passes through the same graphs. This is not ideal, as only parameters intended for optimization should have gradient tracking enabled. By identifying and addressing these leaf nodes, we can avoid the issue and ensure smoother execution of the code. Continuing with the solution, attention is brought to the apply_ellipse_mask function, where a key aspect that can lead to differentiability problems is pointed out. The function's computation of the mask is binary, 0, 1, and not differentiable in axis. To address this, it is recommended to make the mask soft, using a sigmoid function instead. By incorporating this modification, we can enhance the differentiability of the mask computation and improve the overall flow of gradients during optimization. Now, focusing on the revamped implementation of the apply_ellipse_mask function, the code has been optimized to avoid using for loops, which can be slow in PyTorch. By leveraging the inherent vectorized operations in PyTorch, the function's efficiency is enhanced, resulting in faster and more streamlined processing. This adjustment aligns with best practices for working with PyTorch, ensuring optimal performance and reliability in the codebase. In summary, addressing the issue of multiple backward passes through the same graph and enhancing the differentiability of computations are crucial steps in resolving the encounter problem. By restructuring the code to prioritize parameter optimization and incorporating soft masks for improved differentiability, we can overcome the initial obstacles and achieve smoother execution. I hope you found this discussion helpful and informative. Don't forget to like, subscribe, and leave a comment below with your thoughts. Remember, in the world of coding, there's always a solution to every problem. Keep coding and stay curious.